Hey guys, very good evening. This is Yogesh from Forsk Coding School. Please confirm if you can hear me. Okay, now people are uh, saying yes. Okay, Siddharth saying yes. Okay, fine. Now, uh, guys, welcome. To day 5, right? And today is the second last day of our program on deep learning. And tomorrow, right, we would be closing this session. And what we are going to do today, obviously we are going to continue with our CNN learnings. And if I request all of you guys, can you please quickly share me that what was learning from yesterday's session? What was the learnings? Can you please respond to that in the chat window? Siddhant saying 4 steps of CNN. Okay, Santoshini saying CNN. Sweta Mohapatra saying how CNN works. Hemant saying training and testing using CNN. Siddharth Gupta saying convolution. Pooja saying 4 steps, right? Convolution, max pooling, flattening, min-max scaling. Thank you, Rehan. Prashant saying CNN in real life. Pooja saying a small program related to those. Okay. Rohit saying Amnist data set, on CNN layers. Okay, good. Cool. Now, if I quickly recap okay, Karthikeyan saying how to extract the features from the image. I think that's a good statement, Karthikeyan. So let's understand how we started, right? If you remember, guys, on the day 1, that was Monday, we introduced you the concept of deep learning, that where to use deep learning and where not to use deep learning as well, right? That was the case. and in that only, we introduced the concept of neural network and all. On the day 2, we continued with the neural network, right? And there, we finally, came to know that how exactly ANN is, and a lot of, things were there. A lot of things were there, that, number of nodes in the input layer, number of nodes in the hidden layer, number of hidden layers, the number of nodes in the output layer, and that depends whether you are working on a regression problem, if you are working on a binary classification, if you're working on a multi-class classification. So understanding the activation functions as well, understanding the backpropagation as well, understanding the loss function or cost function as well. So a couple of things were there. And finally, we were able to understand that how all of these things are related to each other, and how all of these integrated, all of this integrated stuff makes a complete ANN for you, right? And during that process, during the third step, right, on the third day, right, that was the day 2, if you remember. On the day 3, we actually used Keras, right? And we created a ANN model there. We actually used a Keras library, and we used ANN, and there we used a data set that was churn modeling.csv. You remember that, guys? Churn modeling.csv. And we use this data to perform a classification. So we did that. On the day 4, guys, we talked about a CNN, right? That is convolutional neural network. And during the CNN part, we understood a couple of concepts. And what was those concepts? The concept was like, how the convolution happens, how you apply a ReLU activation function on that, and how you apply max pooling, right? This max pooling is sometimes is also called as downsampling, right? Because in max pooling, the size is reduced, right? Size of the image is reduced. And finally, you flatten the data. And I told you as well, this concept also yesterday, guys, that uh, if you see how a CNN, exactly looks like, basically CNN looks like this, that this is, let's say, a container. And here you have the CNN, right? And whatever the output we get from the CNN, like, whatever. Uh, so guys, are you getting my audio? Because Rohit is saying that no audio. Are you guys getting the audio? Okay, people are getting the audio. Okay. Okay. Uh, just a minute. That is the, just let me just quickly check, and then probably we can. Okay. Okay. Uh, um, okay. What about now, guys? What about now? Is it better than the earlier one? Okay. Okay. Yeah. Good. So, Sylvester sir, is audio better? Sylvester sir is somewhere else now. So, okay. So now, uh, okay. So, so uh, thank you, Vishal. Right. See, guys, that a CNN model is, like this, where CNN is this, and whatever the output we get from the CNN model, it goes to a ANN model, right? And there, right? So, yeah. So, just hold on, guys. Okay, so I think I have done now. Okay, so now this uh, CNN basically does, four activities for you, right? So when we give input data, it performs convolution, it performs ReLU, and then it performs uh, um, max pooling for you, and then finally flattens the data. That flattened data goes to ANN, right? So basically, if we want to classify an image, whether it's a cat and dog, right? Who is doing the classification? Classification is done by ANN only. Then what is the role of the CNN? The role of the CNN, that it will extract the feature from the image, right? And those extracted features will work as an input to our ANN model. Because whether you are using CNN or RNN, whether you are using anything else, if you want to make a regression or if you want to make a classification, you have to use ANN, right? Because that is responsible for that part. And now, after understanding this, let's try to understand a one use case today, and that would be a really interesting part for you guys. And in tomorrow's last session, we will talk about RNN, that how RNN works, right? So today we are going to continue our discussion on the CNN part. Okay, let's see what the problem we are trying to solve, right? What the problem we are trying to solve. So today I'm going to give you a real life project scenario, right? I'm going to give you a real life project scenario, right? And It was a quite decent big project, but I have cut it down a lot of things, and we will understand the basics, but still it is having lot of concepts that will be interesting for you to know, right? So let's start on that part. See, uh, what the scenario is. Let me tell you the story first, right? What the scenario, what the use cases, right? What the use cases. Use cases like this, that there is a client, Mr. X. Mr. X is a client of Forsk, okay? And now he visits our office and says that I want you to develop a project that can classify couple of images I have. Then we ask our question that what are those images all about? Then he say, I have couple of images of Pokemon, right? You know that character, famous character Pokemon, right? And as you know, Pokemon has lot of you know uh, you know uh, uh, different types. Pokemon is of different types. But he said to me that I want you to classify images into three type of Pokemon only. What were those three types? Those three type is that one Pokemon type is Pikachu, another Pokemon type is Bulbasaur, and one, the third type is Charmander. These are the types of the Pokemon. Then what is the problem? The problem is that he's saying that I should give in one image as an input to deep learning model, and then it should give me, and it should classify this image, whether this image is of Pikachu, whether this image is of Bulbasaur, whether this image is of Charmander. Guys, did you get this problem statement? Let me know. Did you get this? That we have to build a deep learning project, and this deep learning project is based on CNN, because here we want to classify the images of a Pokemon, and out of the classification, as of now we are focused on three categories only. One category Pikachu, one more category Bulbasaur, and one more category Charmander. That is there, right? Now we asked our client Mr. X that do you have, right? So will it be a binary classification or a multi-class classification, guys? Can you please respond? Will it be a binary classification or will it be a multi-class classification? Obviously, it is going to be a multi-class. Rohit, it's not binary. In binary, you only have two classes, but here we have three classes, na? Pikachu is one class, Bulbasaur is one class, and Charmander is one more class. So it has to be multi-class, not binary. Rohit, right? Yeah. Now, what we asked Mr. Client, Mr. X, that do you have a data set? Right? Because we will need data set to train our model. Otherwise, how we will train our model, right? So client says to us, no, I only have 4 or 5 images, nothing else. I don't have anything related to data set. Okay, then we have a problem, right? That how we can, get a data set for this problem. At least we should have, 400, 500, 600, images should be there, right? So that, we can train our model. And what should be in the data? We should have an image, and we should have a label, whether this image is of a Pikachu or a Bulbasaur or a Charmander. So we should have a lot of images with us as a data set, and in corresponding to every image, we should have a label. These are the three possible labels. But the client says, I don't have much data, only 4 or 5 images I have. Okay, fine. Then what to do? So now it becomes our responsibility as a company who is developing that, a project for the client, that we should get the data set first, right? Now, guys, can you, comment on this, that how we can get a data set, how we can collect the images and the corresponding label of those images? Guys, what do you say? So Bharat saying Google, Rohit saying Google, Shivam saying Google. Oh, so Shivam is saying from Kaggle, not Google. Okay, but Kaggle is now property of the Google only, right? Anyway, so Shivam is saying Kaggle. Prashant saying please do Google. Okay, okay. So most of the people are suggesting what? They are suggesting that please do the Google, and from Google we can download the images, because we can put a search string Pikachu images, right? Shivam, these images are not on the UCI repository. On the UCI repository you will find most of the CSV files, but this time we are not looking for the CSV file, right? We are looking for images, we are looking for image data, right? So we can do that from the Google, but that would be a manual activity, right? That would be a manual activity, that we have to manually search for each image, each type, and then download them, and use that data set. Can we automate that part? Can we automate that part? That we should run a script, right? I think in the project season you guys are trying that, how you can run a script and launch various tools and something like that from that. I think it will come if it is not covered yet. So we want to automate this, right? And now in this, how we can automate, how we can get a data set. So for that purpose, what we did, guys, we used a API, right? We used an API from a different search engine. And you guys know that Microsoft also has a search engine, right? So, and the name of that search engine is Bing, right? So we used Bing API. And what the API does? So basically API stands for Application Programming Interface. And what we did, we wrote a Python code, and inside that Python code, inside that Python code we called the API, right? That download, right? Download me the images of Pikachu and a Bulbasaur and Charmander and all. So what happened? We called this API from the program, and in the response we got the images, right? In the response we got the images. What is the API? API is basically a HTTP request, and in that request we can send some information to Bing server, right? And from there we will get a response. So this time we were sending information that we need Pikachu images, we need Bulbasaur images, we need Charmander images. So API was doing that. API stands for Application Programming Interface, or any client server application nowadays cannot be developed without making use of a API. Whether it's a makemytrip.com, whether it's a whether it's a Paytm, whether it's a Uber, whether it's a Ola, you talk about any application on your phone, they all use API to connect to the server. So this is client, this is server, and how the communication happens using API. So you call a API, you get a response. You call a API, you get a response. You call a API, you get a response. So this is how it happens, right? So this way, guys, we were able to download, right, a couple of images. So around 150 images for Pikachu, around 150 images for Bulbasaur, and same around around 200 images for Charmander. So that we were able to download those images, right? Now after getting this, this data, now what was the next problem? We had to store this data set somewhere. Then what we did, guys? We stored this data set on the Google Drive, right? We stored this data set on the Google Drive so that we can access this data set from a Colab. Otherwise, we would not be able to train our model. And then what we did, guys, after going through a Keras documentation, we organize this data in such a way on Google Drive so that training of my model becomes possible, right? So how we were organizing this data on the Google Drive, let's see on that part. So we are going to the Google Drive now, right? So let's go to the Google Drive, guys. So here we are, and this is my Google Drive. Can you see my drive? And inside my drive, I created one more folder called dataset, and in this I kept everything. What I kept, let's look at this, right? We created two subfolders inside this dataset folder. One folder was for training set that you can see, right? And another folder was for test set. That means we were putting images that would be used for training purpose in this folder, training underscore set, and we were putting those images which will be used for testing the model. They will be, they were put in here, guys. So two folders. Forget about this single prediction as of now. Only focus on these two. And now let's go inside, right, in each folder, in this folder as well and this whole folder as well, and see how we have organized the data. So can you see training set? So I'm double clicking on this, and there you see three folders have been created, right? And they are created in such a way that one folder name is Bulbasaur, another folder name is Charmander, and one more folder name is Pikachu, right? And here you see, right, each folder name will work as a label in the training data. That is the catch here, guys. Each folder name will work as a label. That means as of now in your training data, you have three folders. That means you have three classes. And whatever images that come under this folder, they all will have the same label Bulbasaur. So can you see? These are the images, right? And the label to all these labels, right? All the label to all of these images is the name of the folder. So do you understand, guys? We have so many images, right? And these images are coming under Bulbasaur. That means their label is Bulbasaur. And similarly, Charmander here, right? So a couple of Charmander images we have in our folder, right? See this? See, this is Charmander. And finally, we are at Pikachu. And here we go inside Pikachu as well. And then we have Pikachu as well, right? And same organization, right, is working with the test data as well, right? And see, so this was training, and here we have test set as well. And in the similar fashion, we have organized our data by creating three folders and naming every folder like Bulbasaur, Charmander, and Pikachu. This is the way only your Keras can read your data and train the model, guys, right? Otherwise, it will not understand. Otherwise, it will not understand, guys, that which image has what label, right? So it will have no idea if you do not organize data in this way. Keras will have no idea that what is the label of this image, what is the label of this image. If you just put all of these images in a folder, no, you don't have to do this. You have to organize your data the way I tell you, right? So guys, is that clear that how we have organized our data? Is that clear with everyone now? Okay, cool. Now guys, understand what is, so uh, uh, so that means these folder names will, these folder names will work as a label for us, right? And the images inside every folder will work as a feature, right? So that is there. Ishika, you can download, or like, we can also share with you, don't worry, right? So that is there. Guys, after solving this problem, that now we have the data set, we have images, and we have the label as well, right? We have, so images are feature here, and the name of the folder is label here. That's it. After understanding this part, right? I will understanding this part. Now, guys, the next problem was there with us. Okay, what was that problem? Do you remember, guys, that yesterday when we were creating a CNN for Amnest data, right? When we were creating a CNN for Amnest data, guys, can someone let me know what size we gave to our CNN model? That this is the size of our images. This is the size of our images. Yes, we gave, guys, 28 by 28 by 1, right? Width, height, and depth. Do you remember that? So why 1? Because we had black and white images, and that's why depth was 1. Now, guys, in that data set, in Amnest data set, all of the images by default were of 28 by 28 size. But in our case, in today's project, what is the problem, guys? Every image is of a different size, different resolution, right? Some image is 150 by 150, right? One image is 200 by 200, another image is 80 by 80, some image is 400 by 350. So there is a variation in the size. Every image is varying. And if your images are of different size, you cannot train your model, because while creating a model for training, you have to specify that what would be the size of my images. And in this case, how to specify that what should be the size of my images? That means we have to do some kind of pre-processing before training the model. Somehow we have to convert all of these images or resize all of these images so that they all become of equal size, right? They become all of equal size. So this resizing we have to do, guys, right? And how we will do that, we'll understand that part. But this was the problem, and we have to solve it. And this will happen in every project. If you are doing any real life project in deep learning, guys, it is very hard that you get all the images of same size. Not possible, right? So that was the one problem. Now, one more problem was also there, right? You have to understand this concept, because these are the all real life scenarios I'm talking about to you. There was one more problem. So, a resizing was an issue for us. Now, guys, this time all images are colored. So what should be the depth in way? What should be the depth? If I ask you, what should be the depth, guys? Obviously 3 should be the depth. So people are okay now. Okay. Now, third problem was something else. What was the third problem that you have to understand, guys, very carefully? What was the problem? The problem is that to train a CNN model, guys, just having 200 images or 500 images or 400 images are not enough. They are not enough. Even though you have downloaded a couple of images, 150, 200, corresponding to every Pokemon type, but still that is not a very good, that is still not a very good data that can give real accurate results for you. Then what we should do? Then, guys, we do one thing, that we have to increase our training data set, right? Increase data set size. Guys, this is the case. But now question comes, how we can increase our training data? We have already downloaded, right? We have already downloaded the required images, and we don't have any more images with us. How we can increase the training size? There is a way to do that, guys. Okay, let me see how we are doing it. For example, in this image, right, we have Ishika. So Ishika is this. So this is Ishika, right? Now, guys, see how we generate more images from this image, from this single image, right? See this. One activity we can do, that maybe we can zoom in this, this image. Maybe we can zoom out this image. Maybe we can, flip it, right? So maybe rotate, by 180-degree, right? We can do this. Maybe we can make it upside down, so rotation can happen, right? Maybe we can tilt this image a little bit like this. Shear, we can shear our images. So, and maybe we can crop this part only. Let's say we can crop this part only. So cropping is also possible. So what happened? Earlier we only had a one image, but now after applying so many operations on the same image, we have, additional images in our database, right? So this will work as a separate image. This will work as a separate image. This will work as a separate image. This will work as a separate and separate. So let's say we are able to generate 6 more images from a single image. And if that is the case, guys, what will happen if in total we have 500 images? If in total we have 500 images, what will become the size of, our data? 500 multiplied with 6, because every image will generate 6 new images, and this time we got 3000 images in my data set. This process, guys, right? This process of generating, right? This process of generating new images is called as data augmentation. We call this process as data augmentation, right? So in most of the cases, right, it is better that you should augment all your images, right? You should augment all of your training data so that you have better model. Guys, is the data augmentation clear to you? We are trying, we are fixing problems one by one, one by one. Is that clear with you? Right? So that is there. So guys, what was the problem? Earlier problem was about resize. We solved it, that we will convert every image to a same size. Then, colored images were there, so we'll make the depth 3. And the third problem was that we will, create more images. And how we will create the more image? We will zoom it, zoom out, we'll crop it, we'll rotate it, we transform it, we'll, flip it, and, we'll do a lot of things. And this way we'll be able to generate new images, right? Because if you see, right, in all the scenarios, my model should give me a right prediction that whether this is the image of Ishika, or whether this is a tilted image of the Ishika, or whether this is just a cropped image of the Ishika, whether it's a zoomed in image of Ishika, whether it's a zoomed out image of the Ishika, right? Whether it's a flipped image, right? It doesn't matter. My model should always give me a prediction that this is Ishika, right? And that's why data augmentation is good process to have if you want to really make your product or really want to make your model robust enough so that it can give the right predictions for you. Guys, I have requested multiple times that whenever I ask you question, please respond. Whenever I ask you a feedback, please respond so that I can understand, are you guys getting it or not? Right? So this is there, right? Guys, now what to do? Now we can move, now because we know how to organize the data on the Google Drive, right? Now we know that how we will handle this data augmentation. Now we need to understand this part in the coding, that how things are happening in the coding section, guys, right? So let's go there and see this part in the code part. So here we are, guys. Can you see? I have a separate IPYNB file today, CNN underscore Pokemon dot this interactive Python notebooks. Now, guys, because my data is right now available on Google Drive, so I need to mount my drive. Guys, did we mount the drive in yesterday's example while going for Amnis data? No, we did not mount because that was not required. We directly downloaded that data set from Keras, right? So we did not, mount our Google Drive. Now, so guys, first we need to, mount our Google Drive. So let's mount our drive. We are connecting. So it's getting initialized. Okay, here we go. We get a authorization code on this link. So we click on that. And here, we have this. We allow the access. So we get the access here. We get the code. We copy it. We paste it here, right? So Control V, pressing Enter button, and here we get the authorization. So my drive is mounted now after this exercise, right? My drive is mounted now. So here we go. Now, guys, what we have to do. So what, what we'll do now, right? No, Hemant, that is not there, right? So what you can do, you can probably manually, do that, or you will find that code on the internet, right? That is, very easy. So now, after doing this, right? After doing this, let's first create a CNN model, guys. Data handling, data augmentation, resizing, we will do later on. But first, let's create a model. So what we are doing, guys, now we are going to create a CNN model, right? Yeah, Ishika. So what we are importing, guys, we are importing sequential, we are importing convolution, max pooling, flatten, and dense. All of these layers are required for us, right? So sequential model we are getting, right? And now this is there. Okay, that's there now. So guys, how we start creating any model? First, we start with creation of an empty container using this sequential class. So we will create an empty model. Then what we are doing, we are adding our first layer that will work as a convolution layer. So can you see, guys? I'm adding 32 filters, and every filter is of size 3 by 3, right? And can you see, guys, I have given an input shape this. I have given an input shape 64 by 64 by 3. Do we have all the images in this size, guys? If I have specified this size, do we have all the images of this size? What do you think? No, we do not have the images of this size. Images are of a different size, right? But I have committed to my deep learning model that I will give you the images of this size only. That means in the pre-processing part, somehow I have to resize all of my images to this size, guys. This size is known as target size. What you call this, guys? You call this size as a target size, right? So this is we have done. Activation is ReLU that you can see. Activation is ReLU now. And After this, what is the next step, guys? We will apply a max pooling. So we have, yeah, Rohit, we can, give a target size. If you wish, you can change it, right? Maybe you can do 150 by 153. Why 3 is required? Because that specifies the depth of a color image. These two parameters you can change. Maybe you can, have something else. Maybe you can have 128 by 28 or, 32 by 32. That is there, right? I will come to the resizing, later on. As of now, I have just given my commitment to the model that I will give all the images in this size, right? So that is there. So we did a max pooling. Again, we are doing a convolution, guys. Again, we are doing a max pooling. And finally, we have flattened our data. Can you see? We have flattened our data, right? Yes, it's mandatory to give the input size. Otherwise, it will not work, guys. You have to, specify the size. So whenever you add a first layer in any sequential model, there you always have to specify the size. That's it. Now, guys, till, from here to here, right? Adding a convolution, max pool, convolution, max pool, and then finally this is step 3 where we are flattening the data. All of this is CNN, right? Because we have already given you that CNN includes what? A convolution, ReLU, max pool, these, right, and flatten. So this is your CNN. Now what will happen? This output will go to our ANN model now for classification, right? So guys, can you see I'm adding my first hidden layer here, and finally I'm adding my output layer here. Now can you guys, give me a answer that how many nodes I should have in the output layer? How many nodes I should have in the output layer, guys? What do you say? Now a lot of people are saying 3. Yes, guys, we have to have 3 nodes. Why we have to have 3 nodes? That is very simple. Because how many classes we have in the data, guys? How many categories we have in the training data? We have 3 classes of of Pokemon, right? One is Pikachu, other one is Charmander, and the other one is Bulbasaur. So we have to specify there. And what should be the activation function in the output layer, guys? What activation function we should have there? Softmax we should have, right? We should have softmax, because a sigmoid is used for binary classification. Because this is a multi-class classification, so you have to use softmax as well. And after this part, I'm just compiling my model, guys. Can you see? I'm just compiling there. I'm specifying a couple of things like what would be the optimizer, what would be the last function, and what is the matrix. So accuracy is the matrix. So this completes our model, guys. That completes our model. Okay. After this, guys, I'm coming to data pre-processing part. Now I'm coming to this discussion that how we are going to resize all of our images into same size 64 by 64 by 3, and how we are going to perform data augmentation. To perform data augmentation, guys, we already have a class in the Keras, and the name of that class is called as image data generator. The name itself says that it is going to generate a data for us, right? So we are going to import the image data generator. And we will need 2 image data generators, guys. One image data generator for training data and one image data generator for test data. So guys, this is the first object. This is the first generator we are creating for our training data. So how we are creating it? We are calling the constructor of that class. Then we are telling that please rescale all of my images. And how we rescale, guys? We are going to divide it by 255. So this way, in Amnist also we divided, if you remember, guys, those pixel values by 255, right? So that is there. And also saying that please share my images, please zoom my images, please do horizontal flip. So this way what will happen, guys? This way it will generate new images for you as well, right? It will generate new images for you as well. And after this, we have to create one more data generator for test data as well. But guys, in the test data, I'm only specifying that you have to rescale. I'm not saying that you have to share. I'm not saying that you have to zoom. I'm not saying that you have to flip. Why I'm not saying? Because I need more data for training purpose, right? Once the training is done, even if I have 2 images in the test, I can, do the prediction. So where is the requirement to have more images? The requirement to have more images is in the training part. So I'm just, creating, I'm just augmenting here, but not here. What will happen only here? Only the scaling will happen, right? Only the division by 255 will happen. So these are my objects, guys. These are my data generators. But now I need to attach these data generators to some data source. I have to tell them that where my data is lying. Then only they can read the data and perform the required activity. So guys, in the next step, this is what I'm doing. Can you see? I have used this generator. The name of that generator is this train underscore data gen. And I'm calling flow from directory. What I specify here, I specify that what is the location of my training images. So here you can see, guys, I have given my path, content, then drive, then go to my drive, then go to the data set, and then go to training set. Inside training set folder, it will find 3 subfolders, one for Pikachu, one for Bulbasaur, and one for Charmander, right? So along with this, I have specified a couple of other things as well. I have specified that keep the target size of images at 64 by 64. What is the meaning here, guys? We are just specifying to our generator that when you generate images, right, please, keep the size of all images at 64 by 64. So guys, during the data augmentation process only, we are converting all of our images into a same size, and the same size is 64 by 64. I will specify this batch size a little later, right? And we have also specified that we have a categorical name to every data, right? So this is there. And similarly, I'm attaching my test data generator with the test directory. So can you see, guys, I have, given the path of test data as well. So I have attached both of the generators now. And here as well, I'm saying that, target size should be 64 by 64. So training images as well as, our test images will be of same size now. And now let's run these, guys. Okay. Now, can you see we got some response? Guys, we have just defined them and we have just attached them. The data generation is not started yet, but they have figured out that you have 445 images belonging to 3 classes in the training, and you have 238 images belonging to 3 classes in the test data as well. So in total, we have 445 images for training purpose and 230 images for testing purpose. And it is also saying that it has 3 classes. We did not specify how many classes we have, right? But because of the data organization that is happening there, from that it got the idea that this data has 3 labels, 3 classes. One Pikachu, one Bulbasaur, and one, a Charmander, right? So this is the way. Now the question is when the data, generation will happen. Data generation will happen when we are going to train our model, guys. So now we are going to, train our model. Can you see, guys? Classifier, that is the name of my model, right? This is the name of your model. So classifier dot fit generator. This time we are not calling fit method, guys. We are calling fit underscore generator. And there we are specifying training set. So we have specified the training set. And along with this, we have specified how many epochs it has to create, right? And here we are saying steps per epoch. That means when 100 steps are complete, count that as one epoch. And what will happen in each step? In each step, guys, we will feed 32 images to our model. Can you see, guys? We have one parameter here, batch size. Do you remember from yesterday, right? We were talking about what is the batch size and what is the epoch. So here, guys, we are keeping batch size as 32. That means in a single time, it will feed 32 images to our model. And when 100, batches are over, that would be counted as one epoch here, right? That would be counted as one epoch. So guys, let's, train our model. So it's running, guys, right? And we are getting a warning as well. It is saying that in a new version of the TensorFlow, you can directly use fit as well, because now that fit model also supports generators, right? But this method will still work. It has given us a warning only, right? This is there. So can you see, guys, we are into epoch 1 out of total 5 epochs, right? The more number of epochs you have, you will have a better, prediction. So this is there, guys. This is there. So it's going on, right? Now, after, so this completes your model creation for a real life problem, guys. Was it interesting to you? Training is going on. It will, it will be trained and then we can use for prediction, right? Don't worry about that. We will share this code with you. So guys, now after this part, can you create your own CNN model and train that? Is it possible that yes, you can also, make your CNN using Keras, right? Yeah, Rohit, yes. Right. So basically, Kavya is saying, sir, can you please explain the image generator part? Okay. See, Kavya, right? This. Kavya, what is the role of image data generator? The role of image data generator is very simple. You have to understand that, right? So see, uh, the role of an image data generator is like this, Kavya, right? Uh, yeah, Satyajit, that is possible. So Ashish, you can fix that if you know what the overfitting is, right? So Kavya, we have data, right? We have the data here. So a couple of images are of a small size, couple of them are bigger in nature. So these are the different size images, right? And now what we are doing, we are attaching a image generator here, right? Image generator here, right? Image generator. What will happen with the image generator? Now it will generate additional images. How? Using, that zoom in, zoom out, using that flip, using that rotate, or whatever, you specify. And along with this, image data generator will also do one thing, that output, in the output, all images would be of size 64 by 64, right? So that is the utility of the image generator, that it is working on my existing data set, Kavya, and converting them to a fixed target size, and also generating additional images, because this image generator is also doing a data augmentation for us. This image generator is also doing data augmentation for us, right? So Kavya, is that clear? And then that you can see in the code as well, Kavya, right? Here we are getting these classes imported. We created two objects, right? We are doing data augmentation for training set only. We are not doing any augmentation for test data because that is not required. You need more images in the training, right? So what it will do during the data augmentation, it will do the shearing, it will do the zoom, it will do the flip, right? Three operations it will apply, right? And this parameter rescale is equal to 1.255. It is saying that we have to feature scale our pixel values, and to feature scale our pixel values we need to divide, right, those values by 255. Okay, so Kavya, you can take your decision that by what angle you want to share your image. So it is just share your image by 20% only. It will zoom your image by 20% only. So you can say no, I don't want. I just want to zoom 10% only, right? I want to zoom, let's say 30% only, right? So that way. So do you want to do horizontal flip or vertical flip? So if you don't want to do vertical flip, don't use that parameter. By default, that is false, right? So if you want to use horizontal flip only, so that you can decide. And basically, Kavya, what we need to do, we need to understand that on the Keras site, keras.io, every documentation is available. So what we can do, Kavya, we can go to Keras and look what different parameters we can have and what we can use, right? So so this let's use that documentation, Kavya. I'll just show that. See, okay, here we go. This is my Keras, right? And what should I search here? This image data generator, and see, can you see image data pre-processing? So we go there, image data pre-processing. Okay, so it's just opening that page. Can I see something? It's a little slow. Let's wait. It will open up. Maybe I can go there. Do have something here? Okay, can I go to data pre-processing? Okay, data pre-processing is there. Okay, so image data processing is there. Okay, I can go there, image data processing. In the image data processing, there we have a, which method we were using? We were using this method. What was the name? Flow from directory, right? We are using that method, flow from directory. Okay, see, this is image data set from directory. Okay, anything else? Load image function is there. img2 array is there. Image data generator class. Can you see this, right? And here, can you see, Kavya? There are so many parameters that you can specify, right? You can specify the rescale, you can specify vertical flip, you can specify horizontal flip. There are a lot of, and you can read the details about everything. So shear image, zoom image, rotation range, right? A lot of things are there if you see. And these are the parameters, and you can read more around every parameter and see which one you can use, and they will specify the range as well, right? That what is there. So you can read about the CVAL. This is there, Kavya. So a lot of documentation is available. You need to just sit and read a lot of documents so that you understand the complete picture around that. So Kavya, is that clear now to you? And from there, we get an idea that what values we can use. Kavya, do you get it? Okay. So Kavya is saying, thank you, sir. Okay. Now, Shruti Chaudhary is saying, sir, what it does, what it does, what? It is saying that what is the meaning of this rescale, right? What is the meaning of this rescale? So meaning of this is, do we have somewhere rescale? Do we have rescale somewhere? Yeah. So can you see, Shruti? Rescaling factor, right? That means, we have to perform a rescaling. So how the rescaling happens, let's understand that part. So here we do. So it is saying that as of now, in our case, rescaling factor is how much? Rescale is equal to 1 point. 1 point means it is a float value. So 1.0 divided by 255 is the rescaling, right? And what will happen now? Now we will multiply this, right? We will multiply with this with every pixel. So if we multiply it with 100, or so every pixel will multiply with this. So what is the meaning of this? Basically, you are dividing every pixel by 255. And do you remember in the amnes data we were doing this, right? We were dividing every pixel data by 255, and this way, feature scaling was done in the image. Shruti, do you get it now? Okay, right. So that one dot is like, a float value, so that you multiply this, right, to this, so you get a floating number, right? It won't be an integer division. Otherwise, it will become an integer division. If I only say one, multiply 1 upon 255 with 100, what will happen in that case? It will give a integer output only, right? Yeah, Kavya, this rescaling is actually doing min-max scaling only for you, right? Min-max scaling for you only, right? Because minimum value of the pixel is 0 and maximum value is 255. So what will happen in that case? X minus minimum, which is 0, divided by maximum 255 minus 0. This, so actually you are doing this only, right? So this is min-max only. So that is there. So that is there. Now, guys, after this, you can see, our uh, epochs got completed. I think first epoch got completed, and we will start with the next epoch, and so, right? So this is there. Now, guys, I have a code which you can use for your prediction as well, right? I have a code which you can use for prediction here. So okay, see, I think something is hidden, so we'll load something else. Okay, so here, okay, so I have a lot of code actually. So else, if Shivam it's not there, I will add it. Don't worry, right? No, cover, it's working with me, right? It's working with me, right? Yeah. Now, guys, uh, see, one more important stuff. I just want to, so, see, now we want to understand a one more important concept, guys. We want to understand a one more important concept. And that concept is known as transfer learning in deep learning. One more concept I want to, give you is known as transfer learning. So see this here, I'm just going to clean it. Okay, see what is, a transfer learning is. See, guys, I told you, right, that this is your CNN, and this is your ANN, right? Here you have in and here you have out, right? And we train this model. Then what happens now? Guys, this model is trained, right? This model has been trained. But sometimes what happens, we do not have enough data to train our model. We do not have enough data to train our model. Okay, then what happens in that case? How we can train our model? In that case, guys, in that case, what we do, right? We can do one thing, that we can use, instead of our own CNN, we can use someone else CNN, and those CNN, right, or those models which are trained by someone else, right, they are called as pre-trained models. They're called as pre-trained model. That means someone else has trained them and we are going to use them. One of the most popular pre-trained model in the industry and the research domain, this is called as VGG16. VGG16. What comes in the VGG16, guys? If you take the VGG16 model, it will have the same architecture. It will have a CNN first, right? And then it will have a ANN, right? This is there. Now, what we do in the transfer learning, guys? What we do in the transfer learning? In transfer learning, we do one thing that is very important to understand, guys. What we do, in transfer learning, we remove our own CNN. We don't take it. Then what we take it? We take this CNN. So we take VGG here, right? So we take VGG16, right? Okay. And we do one more thing. We do not include this ANN. That is not required, right? And we take our ONN here, ANN here, right? So now what happened? In this package, guys, right, this CNN portion is called top, right? This is called base, not top. This is called base and this is top, right? So this is there, guys. So what has happened, guys? Instead of creating own CNN, instead of training our own CNN, we have already taken the VGG16 here, and whatever the output we get from this will go to our own ANN now. And now, while training this configuration, guys, with our data, what we do, we freeze our weights here. We freeze the weights of this. Otherwise, there is no use, right? If we are not able to use the pre-trained model means the optimized weights. So we do not change them here. So we can freeze them, right? So while training, the weights will not update in this. The weights will only update in the ANN. So how we do in the code, let's see that part. So here you see, right? Can you see this? We are doing this from Keras.applications import VGG16, right? So we imported VGG16 from the Keras itself. It comes with Keras, right? And after that, what we are doing, we are creating an object of the VGG16. Can you see this? We are saying that please initialize the weights from ImageNet. So ImageNet is a data set, guys. ImageNet is a data set. I will explain that data set later. And now we are saying that include top is equal to false. What is the meaning of this? The meaning of this is that please do not include the ANN. I just want to add the base part. I just want to add the CNN part. So I'm just saying false. So it will not include the top. It will not include the ANN. Which ANN? This ANN it will not include, right? So that is there, guys. And I've specified the input shape as well. So you can specify any input shape here. So this is the input shape. If you specify 150 by 150, you will have to convert all of your images into 150 by 150. So now this convolution base will work for you, right? So what we are doing now, guys, we are creating an empty sequential model here, right? And then instead of creating our own convolution, what we are adding? We are adding this. this one which we got from VGG16, right? And now we are not doing anything. We are not adding max pooling. We are not, doing anything else. What we are doing, we are, doing this, that now after this, we are directly flattening our data, right? And then adding our own ANN. And after that, we are also specifying one thing, guys. Can you see? I have specified that convolution underscore base dot trainable is equal to false. That means please do not train the convolution base. Please do not train this. Only train what? Our ANN model. So guys, did you get the transfer learning? I will explain what the ImageNet is after this. Guys, did you get that how we can use a pre-trained model in deep learning? Is that clear with everyone? Okay, Kavya, because convolution, this that you have added, that VGG16, right? This VGG16 has convolution, max pool, and everything, but flattening is not there. You have to flatten it separately, right? And Swati is saying, so why pre-trained model is required? The pre-trained model is required, Swati, because sometimes we may not have enough images that can train our model very well. And in that case, what we can do, we can use a pre-trained model, right? Swati, is that clear now? And these pre-trained models are trained on millions of images. So now let me tell you what the ImageNet is, right? So let me tell you what the ImageNet is. Here we go. So let's search for ImageNet, right? ImageNet. A very interesting story I will tell you. Yeah, Prashant, you have to look back, the concept again in the video, then you will understand it, right? So, just hold on. Let me see. Okay, it's not. So can you see? We have this ImageNet, right? So see, we can, okay. This is where we get. Okay. And can you see this, guys? In the ImageNet, how many images we have? We have 14 million images. So this VGG16 has been trained with 14 million images, first of all, guys, right? And how many classes, how many categories of these 14 million images? The total 20,000 categories, more than 20,000 categories have been, there. Using such a huge data, this model has been trained. And now you can understand, Swati, that why this can really help you. Do you get it, Swati, now? And now there is a question that you should have, that how come we can train a model with 14 million images? How come, right? Will it require 1 year, 2 year, 3 year? How much time will it require? Because guys, what was done, you have to understand, right? What was done, guys, 14 million images were taken, and initially there was no label with these images. There was no label. right? We did not know what the image is, right? So what we had to do, we had to manually open each and every image and label it, whether it's a cat, whether it's a dog, whether it's, you know, a strawberry, whether it's a balloon, whether it's that, whether it's that, right? So we had to do it manually. Can we do it manually? I think this VG16 is from probably some uh, Amazon or some Oxford University or something. So, guys, you know, uh, how we can do that? For that, guys, there is a activity which is called as crowdsourcing. There is an activity which is called as crowdsourcing, guys, right? And what happens in the crowdsourcing? In crowdsourcing, we distribute these images, right, to volunteers who want to participate in this activity, right? And people across the globe participated in this event. Universities, research groups, volunteers, you know, different organizations, they all worked together, and then finally a labeling of the 14 million images was done. But how was, you know, it distributed? Is it possible to manually distribute, like, okay, Swati, you take 100 images and label them, right? Bharat, you take 200 images and label them. Kavya, you take, you know, so much images and label them. Akshata, you know, take these images and label them and give it to, you know, give back to me. For that purpose, they used a crowdsourcing platform, guys, that is known as Mechanical Turk. It is a platform by Amazon, right? Mechanical Turk. So that was used to distribute the images and everything, right? And people used Mechanical Turk, you know, a very a powerful tool, right? That was used to do this activity. So it took around, you know, it took years actually, right? That, you know, and then this job was done. Is that clear, Akshita? Is ImageNet clear now? What the ImageNet is a collection of images, right? That's it. Bharat, you can you know, watch the video again. If you don't understand that, I will explain tomorrow, right? Today I'm having some problem in my system. Anyway, we can open from here if it works. Seeing some issue with that. Okay. Okay. So that is, I think Nat has some issue today with my, or maybe some caching problem. I need to clean it up. So guys, that was the story for today. If we quickly recap, we will share these codes with you, don't worry, right? We quickly recap what was the main focus today, guys. The main focus today was that how we can handle a real data set of colored images in which we have images of different size. And the problem also lies that we do not have enough data to train the model. In that case, what we can do that, right? What we can do that. In that case, we can perform data augmentation, right? And after that, we also understood one concept, right? We also understood one concept, that how you can use a pre-trained model, right? And then we understood the concept of ImageNet and every, that all was there for us today, guys. And I leave testing part to you guys, you know. You can just do a Google on Stack Overflow, that once your CNN model is ready, how you can, you know, use a method to test a single image or set of images. That is not a big deal, right? It can be a kind of a home exercise for you. Shubham, it's an exercise for you, right? That please do a Stack Overflow, right? And find out that how we perform prediction. That would be a one single line statement that you have to look on the Google. Shubham, is that clear? This is the assignment for you. Guys, is that clear? Okay, Ashi. Yeah. Shubham, did you get it? So now, guys, uh, tomorrow, in tomorrow's class, we will understand about RNN part, right? And RNN is recurrent neural network. Again, an interesting topic to have, a very interesting one. And how it works, right? How RNN works, we will understand that part and will create a real problem, will solve a real problem by creating a RNN model for us, right? For a RNN model for us. Yeah, Bharat, you're right. Right? Yeah. So, this is how we use a pre-trained model. So, guys, one thing, deep learning is requires effort from you. I'm just repeating again, right? By just looking at the videos, right, and by just assuming that you get the code and things would be easy for you to manage. No, right? No. Rohit, yes, right? Yeah. So VGG16 is a pre-trained model that can be used to solve any problem, Bharat, right? And we use that for solving, solving that Pokemon problem as well, right? Bharat, it can be used in any problem. So Shubham is saying from where we can learn deep learning. Okay, so I was saying like that, guys. You have to, if you are finding it interesting, really it is challenging, no doubt about it, right? And you can see the numbers, that number of people that are in the room. It requires effort, right? It requires a effort. It's not a Netflix movie or it's Amazon Prime movie, right? You have to put real efforts to understand this. And if you can really make a good project, you can really understand that how it can be really helpful in your placement in or job opportunities, right? So this is there. So Rohit, when initializing this, right, when you are initializing this part, Rohit, here only we are getting all the weights and everything here in this. So you are initializing this VGC16 weights is equal to ImageNet, right? So we got everything in this convolution base, right? That is there. Rohit, is that clear now? Yeah, okay. So now, guys, tomorrow we are going to discuss, that is the last topic for RNN. Shubham, I don't remember as such any YouTube channel, but I can, give a couple of names probably. There is a site called Machine Learning Mastery, right? Probably you can refer that. MachineLearningMastery.com. That is there, right? Bharat, that code is not for you. So, Shubham, maybe you can follow this, right? No, Akshita, right? No. So this is there. So you can follow this, Shubham. It has a lot of, articles, very good articles it has, right? And then, you will understand that. And I think one more is there, Pi image search, right? Pi image search. So that you can go and, that will help you out. Pi image search. It's a site name, Shubham. You can note it down. And, you can see this. Okay. Someone was telling me about YOLO. What is YOLO? Who was asking that question? And this. Yeah, on this site, machinelearningmastery.com and PyMA says there are a lot of projects, Bharat. Okay, Shavik was asking this. So what is computer vision, right? So I tell you that computer vision is like, uh, kind of based, you have to identify object in an image, or you have to recognize someone in the image or a video. That is all computer vision, right? Image से image को identify करना, image में क्या लिखा हुआ है उसको पढ़ना. That is all computer vision. Let's say some text is written in the image, right? Let's say some text is written in the image. This is actually an image, but some text is written. So can we extract this text? Can we extract this text? This is known as OCR, optical character recognition, right? This is there. And so this is also a computer vision. And now, guys, there are couple of libraries other than Keras. There are a couple of libraries which can be, used for computer vision. And you must have heard of a name about OpenCV. Have you heard about this, guys? OpenCV. OpenCV. CV stands for computer vision, guys, right? CV stands for a computer vision. So this library is pretty much used. There is one more library called YOLO. So YOLO is also a library which can be used for computer vision purpose. And what is good about these libraries, guys? These libraries are already trained models. These libraries are already trained models like VG16 and so. But VG16 does not give you any method or method to use that. You always have to integrate it with some other model, but you can directly use them. YOLO, you can use them. OpenCV, you can use them, right? So that is there. Souvik, is that clear now? Okay, so Bharat, you are at a very wrong place actually. So this is it, guys, right? This is it for. So Mohammed Faizan is saying, sir, in object detection, what will be better? In object detection, you can use OpenCV. And what is good about OpenCV, Mohammed Faizan, you can integrate the OpenCV library even on the Raspberry Pi, right? So what you can do on the Raspberry Pi, you can install OpenCV, you can attach a camera, and you can make a mini project that can detect your objects and all. Faizan. That is there. Faizan, did you get it? So Rohit, there is no job in the neural network. The jobs are in the deep learning. Jobs are in the AI, right? Neural network is just a concept, guys. Neural network is just a concept, and you use neural network to solve some problems. So Rohit, there are a lot of jobs in India as of now. There are a lot of companies who are working deep learning and AI domain, right? The only thing that you need to have, that you should basically make some projects, right? Yeah, Rohit, you can go deep in the deep learning, right? That is there. There are a lot of projects, Faizan, right? You can think of anything around that, right? So let me explain one project to you that our company, as of now, this. So guys, there is a team, there is a development team in the Forsk. Guys, I think you don't know, we have a development team as well. The team name is Forsk Technologies that works into development. And this for training, guys, we have this Forsk coding school, right? We have this Forsk coding school. So there is a team in this Forsk technology which is working for a Japanese customer. And what they guys are doing as of now, around 8 to 10 people are working in that team. What they guys are doing, so basically they are trying to make a project this way that in Japan, right, what they want to implement, what the company wants to implement, that they are making a product for a school. So let's say a kid writes some answers on the answer sheet, right? And obviously it would be a mathematical, or some mathematical, a problem. So it would be a maths, a book or maths copy. They will scan this, and after the scanning, they want to extract all the texts that the student has written, right? And now they want to, compare that where he has done something wrong, where he has done right. So they want to, automate this, this evaluation, copy evaluation mechanism. Did you get what they are trying to, uh, solve, guys? Did you get this project, what I'm talking about? Yeah, Rohit saying yes, right? So this is, they are doing something, and they have been doing it, doing on this project for last 6 months, I think, on last 6 months. And generally what has happened, guys, I tell you a story. This story is also good, that we have done all of the hiring for this team from, from Forsk coding school only. Those people who have taken training from us, right? Those people who have, got a letter from us or certificate from us, right? Then we ask them that if you are interested to, take an internship in this, right, you can apply for this, right? So we always hire resources for our technical team. So we generally hire freshers as an intern, right? So they work with us as an intern for 6 to 8 months. And then what we do, guys, right? Obviously, during the internship, we pay them. Okay. During the internship, we pay them. And after 6 to 8 months, what we do, that client, directly hires these people. So client, that Japanese company, right? Now after, couple of months, that company will directly hire these interns, right? So they will move from Forsk technology to that company. And that has happened with multiple people, right? That has happened with the multiple people. Even a lot of faculties, I know 5, 6 faculties so far, they have moved from teaching domain to development domain, even after 10 years of teaching. So that is there, guys, right? So no, Mohammed Faizan, for object detection, you don't have to create any data set. You can directly use OpenCV or YOLO kind of libraries, right? That is there. So guys, if you have any questions, I can answer that. Otherwise, we will, Shubham saying, sir, how we can apply for internship? Shubham, generally what we do whenever we have a new opportunity, we share these opportunities with the people who are registered with us, right? Whom we have the contact details, right? So we have all of your contact details, right? Because you have, registered for the course. So, you know, um, we, message you that we have an internship opportunity. If you want to apply, you have an interview, right? And everything goes on that way. And then finally, you get a offer letter. Is that clear, Shubham, now? Right? Yeah, Akshita saying happy Ganesh Chaturthi. Thank you. Shubham, there are lots of job in the machine learning, right? People, even the freshers, are getting very good packages. Even freshers are getting ready. Thank you, Abhay sir. Right. Ashish, I think better I will talk about tomorrow. Please ask me this tomorrow. Ashish, is it okay with you? I'll explain with some scenario actually. Right. Yeah, why not, Mohammed Faizan? Why not? You can. Right. Bharat, there are a lot of portals, right? Audio for audio data set, you have a library as well in Python, Prashant, right? That library, I think, is Pi Audio something, right? So you can use that library that will solve your problem, Prashant, right? Uh, Python library for audio data. I think that is, this Pi audio analysis. This is the library that you can use, Prashant, that will solve your problem, right? Prashant? Shubham, we can do one thing. We can organize a 1 hour session sometime in the weekend, and we can take up all your questions which are related to how to find an internship, how to find a job, right? So that is there. Yeah, Akshita. As of now, there are a lot of people in the project season, right? There are a lot of people. There are around 200 people in the project season. What will happen in the project season? They will make a real life project. I think a couple of them are here as well, right? Some of the people from that project season are here as well. They will create a real life project, and before they work on the project, we are giving a training them as well, right? So this program is for 30 days. I think you are part of that, Akshita, or not? And in the first week, training will happen. In the next 2 week, development will happen. In the third week, things would be wrapped up. Documentation and everything will be there, and that would be, and we'll issue a letter of internship as well, right? I think you are talking about that internship which we hired people, right? I think you are talking about that, right? Uh, okay, so yes, that happens, Akshita, right? Because a company may have a different kind of tools and processes. So they give you some time, and during that internship, obviously you have to work, but at the same time, you learn a lot of things as well, Akshita, right? Already a lot of people who were fresher, they joined us as an intern, but yes, during their engineering or during their studies, they already have done some kind of projects in machine learning or deep learning. And that's why I'm saying to you that please join a project season, because that will help you get a one project, right? उसके बहाने एक project बन जाएगा आप लोगों का, and that will fetch you internship opportunities at many places, Akshata. So guys, let me thank you, Akshata. So are you from Maharashtra, Akshata? I'm just okay, you are from Karnataka. Okay, thank you. So you are close to Silicon Valley of India, right? So don't worry about the opportunities. You have a lot of opportunities in the Bangalore, but your resume should be strong enough so that it's not rejected, it's filtered out, it is selected, and then they call you for the interview as well, right? So your resume should be strong. It should really give some projects. So by going through, you know so that would be there. uh, Shubham, I think better site is Kaggle. Go on the Kaggle, there are a lot of projects. Kaggle is all about projects only, right? And even, we keep on working on the new projects, right? Even we keep on working on the new projects. So stay in touch, stay connected, and you'll get updates as well, right? So guys, that's it for today. And couple of people have registered for the certificate in the deep learning, right? And still there is a chance that you can go and register yourself for the certificate, guys, in the deep learning. Sylvester sir, can you please share the link with them?
What happened, sir?
Please share that certificate registration link.
Which link?
Certificate.
Okay.
सिल्वेस्टर सर का ध्यान कहीं और लग रहा मुझे. Anyway, so guys, we have already completed CNN and ENN project, right? Okay, Ishika, I will try to put that code as well, right, in the drive. Don't worry. So guys, see you tomorrow at 4 p.m. Thank you, right? I hope आज भी मजा आया होगा लोगों को. आज भी कुछ चीजें इंटरेस्टिंग आपको सीखने को मिली होंगी, right? Okay guys, see you, bye bye, take care.